All right. So we're going to do a quick sound check before we start. So this is a quick sound check again. Let's make sure that the pencil works. Everything seems to be working good. All right. So this is going to be the second algebra session. This will be a little shorter as it happens. Some things came up today that I need to take care of. So this will be a relatively short session. What I want to do is I want to continue with this great algebra book by Gelfand. So the book, as you can see, is in Russian, but I'll be translating as I go. And I want to focus on these problems here in this section 5. And section 5 here focuses on multiplication. So we all know how to multiply integers. We know our table of multiplication. So let's begin. The first problem, actually, let's do an example real quick. So if I wanted to do 17 times 38 using the table of multiplication, we know how to do that, right? 7 times 8 gives me 56. I write the 6 and save the 5. 1 times 8 is 8, and the 5 gives me 13. 5, that was the carry. Then we go 3 times 7, 21. There's our 1. We carry the 2. 3 times 1 is 3. Added the 2 is 5. And so in total, we get 6, 4, 6. And that's our answer. And that's exactly what we see here on the right in the book. And what he shows here is that multiplication is commutative. Last time we talked about commutativity of multiplication and addition. In other words, you could take 38 and multiply by 17, and you'd still get the same answer, 646. In other words, 17 38s and 38 17s gives me the same number, 646. So having refreshed that, let's go to the first problem. And the first problem, number 3 here in the book, says take any 3-digit number, let's say 232 here, and multiply it by 1001. All right, so that's the multiplication we want to do, and we want to see what we get. So first, let's do this multiplication using the table method that we know. So 1001 times 232. 1 times 2 is 2. 0 times 2 is 0. 0 times 2 is 0. 1 times 2, 2. Plus 3 times 1, 3. 3 times 0, 0. 3 times 0, 0. 3 times 1, 3. Plus 2 times 1, 2. 2 times 0, 0. 2 times 0, 0. 2 times 1, 2. So what do we see? The 2 comes down, the 3 comes down, the 2 comes down, the 2 comes down, the 3 comes down, the 2 comes down. So look what we see. We see that we have this 3-digit number that we picked originally, the 232. It's now been repeated twice. See, we see those digits, 2 times 232, and here's the second copy, 232. Let's try this again. Let's do another example. We can pick any other number here. Let's say I do 1001 times 141. 1 times 1, 1, 0, 0. So it's 1, 0, 0, 1 plus 4, 0, 0, 4 plus 1, 0, 0, 1. And when we tally these up, we get 1, 4, 1, 1, 4, 1. And again, we see the numbers repeated twice. So what's the conclusion here? The conclusion is that if I take a 3-digit number and I try to multiply it by 1001, what I do is I repeat that 3-digit number twice. So can I think of this a little sort of in a bit maybe more general way as opposed to this multiplication, this table multiplication method? And this is the way I like to think about it. what would happen if I took 141 and try to multiply it by just 1000? So we know that when we multiply by 10, we just add a 0 to the number. When we multiply by 100, we add 2 zeros. So when I multiply by 1000, I'm going to add 3 zeros. 1, 2, 3. So look, we have 3 zeros at the end here. 3 zeros, right? And then what am I doing? So I'm also multiplying it by 1, right? 1001. And 141 times 1 is, of course, 141. So what happens when I add these two numbers? You can see that the 141 takes the place of these 3 zeros, right? So here's the way we can write it. And this is, in a sense, the distributive property that we talked about. We can do the following. We can say 141 multiplied by 1001 is the same as 141 multiplied by, now notice how I'm going to separate this 1001 into 1000 plus 1. Now we invoke the distributive property. This is 141 times 1000 plus 141 times 1. And as we saw, when we multiply by 1000, we just add 3 zeros at the end. 1, 2, 3 plus, well, any number times 1 is that number itself. And of course, since it's a 3-digit number, it's going to take the place of these 3 zeros. And we're going to get 141, 141. And 141 is an arbitrary 3-digit number that I picked. It was absolutely arbitrary. So you can pick any 3-digit number and replace this and redo this whole procedure, replacing 141 with a number of your choice. And so you will get the same thing, NPQ, NPQ, where NPQ are these digits of the 3-digit number. Okay? So that's the moral of the first problem. That's the lesson you take away. You take a 3-digit number, you multiply by 1001, and you repeat that number twice. Okay, so let's go to exercise 4. And exercise 4 tries to generalize this concept even further. So he says, what would happen if I took 1, 2, 3, 4, so 4 tens, 2, 3, 4, and 1 at the end, this number, and I try to multiply it by 57. What would happen here? Okay, let's do a quick experiment. Let's do a quick experiment. Suppose I try to just multiply 101 by 57. Well, this is similar to what we just did, right? Instead of 1001, I have 101. We saw one way of dealing with this is through the distributive property by breaking away that 1. And now we distribute the 57. So we get 57 times 100 plus 57 times 1. And 57 times 100 is, of course, just 57 with 2 zeros attached at the end, plus 57 times 1 is 57. Now look, 57 is a 2-digit number, and I have 2 zeros. So the 57 is going to replace those 2 zeros, and we're going to get 57, 57. So what does this tell me? This tells me if instead of 3 digits, I have a 2-digit number, then instead of multiplying by 1001, I should multiply by 101 to get to repeat those digits twice. Okay, so we just saw that if I take 57 and multiply by 101, I'm repeating these digits twice, right? Now let's assume instead of 101, I have the following. So I have 101 times, and let's see, how many digits do I have? 1, 2, 3, 4, 5, 6. So we're ignoring 6 digits. Let's multiply by that many zeros. So 1, 2, 3, 4, 5, 6. So we're going to multiply by a million. 101 by a million. Okay, so now suppose I take this number here and I try to multiply it by 57. Well, commutative property and associative property together, they tell me that I can do 101 times 57 and then multiply by the million. 101 times 57 we just did. That just repeats the 2 digits of 57. And then I'm multiplying by the million, which does what? Just attaches 6 zeros at the end. 57, and 6 zeros. 1, 2, 3, 4, 5, 6. Right? So what happened? When I take the, if I ignore these ones here, the ones here, and I take the 57, and I imagine they're all zeros, and I take this 57 and multiply by that number, what I get is the repetition of the digits of 57 twice. That's because of this 101 here. And then we attach the zeros at the end. Okay, so let's go a step further here, and let's try the following. So now, suppose I have the following. So 1, 0, 1, 0. And 1, and so this is what I'm trying to multiply, right? Well, we already saw that I can rewrite this as 101 times 10, right? Because multiplying by 10 just attaches 0 at the end. And so if I wanted to multiply this number by 57, this is the same as 101 times 57 times the 10. Well, 101 times 57 was what? That was just the repetition of the digits. And times 10 just attaches a 0 at the end. Like so. Fine. What happens if I have an extra 1 here, though? So what could I do about this? How can I write this? Well, I can rewrite this number as 10,000 plus 101, right? 10,000, 101. And now if I wanted to multiply this by 57, I would invoke distributive property again. Now, multiplying by 10,000 just puts 4 zeros at the end. 1, 2, 3, 4. And then plus, well, times 101 we just did. That's the repetition of 57 2 times. Now notice what happens. We have 4 zeros and we have 4 digits. So these 4 zeros are going to be replaced with these 4 digits. This is similar to the exercises we were doing before, what we just saw before. And so my final answer is 57. That's this first 57. And then these 4 digits here, 57, 57. So what am I saying here? I'm saying that when I multiply, when I had 3 ones with zeros between them, I have 3 pairs or 3 57s attached next to each other. Okay, so from this observation, I look at my original number and I say how many ones do I have with zeros in between them? Well, there's 1, 2, 3, 4, 5. I have 5 ones with zeros between each pair of ones. That's gonna give me 5 57s. So 57, 57, 57, 57, 57. There we are. Okay, and that's my answer. So this is a common technique in math. When you're looking at something like this and you're just not sure, start from a simpler version. Notice how I first isolated the 101 and said, okay, what happens if I do 57 times 101? And I saw that the digits 5 and 7 repeat twice. Okay, then from there I said, all right, let me imagine that after 101, I just have zeros like I did here. What would that give me? Well, that would give me the 57, 57 and a bunch of zeros. All right, I said, what if instead of 101, I had 1,010? I did that multiplication and I see this extra 0 at the end. Okay, and so on, and this process continues. All right, what if instead of 1,010, I had 10,101? So the first 5 digits of this number, and I see what happens here. Right, so 3 ones, and then it's pattern matching. So 3 ones gave me 3 pairs of 5 sevens. How many ones do I have here? 3, 4, 5. That's 5 pairs of 5 of this 5 7 digits. And there's my final answer. Okay, so that's number 4. Moving on to number 5. So number 5 says, take the number 10001 and try to multiply it by 10203040 4050, and see what you get. Okay, so what have we learned here? We've learned that when I take, so first of all, we've learned that when we see expressions like this, we can invoke our distributive property and we can rewrite them. We can rewrite this number here as 10,000 plus 1. Now this is being multiplied by 10, 20, 30, 40, 50, right? Now we invoke distributive property. So we get 10,000 times this number 10, 20, 30, 40, 50 plus 1 times this number. Well, 1 times anything is itself. So this expression doesn't change my number. Now, when I multiply by 10,000, I know what happens, right? I attach 4 zeros at the end here. So I have 10, 20, 30, 40, 50. Now I'm going to put 4 more zeros. So 1, 2, 3, 4. Now I'm adding this number. So in this specific example, it's helpful to think of addition in a column like we're used to doing. So how many digits are in this number? Let's think. So I have 10. So 1, 2, 3, 4, 5, right? So 5 tens. So each one of those tens has two digits, a number and a zero, number and zero, number and zero, number, zero, number, zero. So that's 10 digits. So 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So starting from here, we can write our number. So that's 1, 0, 2, 0, 3, 0, 4, 0, 5, 0. There we go. So now we're going to add. Now look what we get. So 0. Notice how the last 5 digits of the bottom number have zeros above them. So those just get copied. Nothing happens to those. There we go. Now, these change, right? 5 plus 3 gives me 8, 0 plus 0, 0, 4 plus 2, 6, 0 plus 0, 0, 3 plus 1, 4, 0, 2, 0, 1. All right, and I have my my answer. So again, distributive property helps me out here because again, I take my number, I multiply by 10,000. That tells me put the zeros at the end here. Oh, did we put 5? We put 5. We were supposed to put 4. Let's do this again. So notice 10,000 here has 4 zeros. No, we did put 4. Never mind. Never mind. So this tells me put 4 zeros at the end. There it is. 1, 2, 3, 4. There are my 4 zeros. Now I'm supposed to add to that this number. So because these 5 last digits are zeros, the 5 last digits of the bottom number remain unchanged. So those just copy, right? So 0, 4, 0, 5, 0 at the end. And now we go from there. So 5 plus 3, 0 plus 0, 4 plus 2, 0 plus 0, 3 plus 1, and so on. Okay, so here's an example where adding in a column was helpful like this. So let's go to number 6. Number 6 says take the number 1, 1, 1, 1, 1, so 5 ones, and we want to multiply it by 4 ones. So what's the answer here? Let's see. Now again, it is very helpful to take this number and try to break it up. What will I get? Well, I can rewrite this multiplication as, so this number will be 1,000 plus 100 plus 10 plus 1, right? This is 1,111. 1,111. Okay, so now we use distributive property. Multiplying by 0 says attach 3 zeros at the end. So 1, 1, 1, 1 with 3 zeros plus. Well, multiplying by 100 says attach 2 zeros at the end. So 2 zeros at the end. And then 5, excuse me, 5, 3, 4, 5, and then 5 ones. So 1, 2, 3, 4, 5. Then multiplying by tens as a touch only 1 0 at the end. So 0, 1, 2, 3, 4, 5. And then multiplying by 1 is just these 5 ones here. No 0 at the end. So 1, 1, 1, 1, 1. Now, so notice when we add, these are 3 zeros with the 1 on the bottom. So that's just the 1. Here we have 2 ones. They add to 2. Here we have 3 ones. They add to 3. Here we have 4 ones. That's 4, another 4 ones. 4 and 3 ones. 3 and 2 ones. 2 and 1, 1. So notice what happens. The numbers, the digits have been reversed. Okay, so 1, 2, 3, 4, 4, 3, 2, 1, reversed. And just as a matter of practice, recall that if I want to take, let's say, 2-digit number, and I want to multiply by something such that these digits get replicated twice. So I want to multiply by something such that the result is 34. 34, the thing you want to multiply by was 101. Okay? And again, why was that? Because multiplying by 100 would put 2 zeros at the end, and then multiplying by 1 would replace those 2 zeros with the 34 itself. All right. So let's do a quick check here. Everything seems good. Moving on. So the next problem is maybe more interesting, a bit more challenging. So let's see. We have a 6-digit number. So 1. I know the first digit's a 1. Then the other 5, I don't know, but here's what I know about them. So we'll call this one A, this one B, this one will be C, D, and E. And now this number has been multiplied by 3, and the result is that this 1 has been reversed. So the 1 is now here. And then all the other digits, all these 5 unknown digits, are the same. So this is A, this is B, this is C, this is D, and this is E. So I hope this makes sense. So your initial number, whatever it is, its first digit is 1, and then we have 5 digits. So this number is being multiplied by 3, and the result is that the 1 is now at the end, and these 5 digits that were at the end are now in the front. And our job is to figure out what this initial number was. Okay? All right. So notice that let's start from the beginning here. Let's start from the right. So E times 3, whatever E was, it's some digit, times 3 gave me a 1. There is only one digit I know that multiplied by 3 has a result with a 1 at the end, and that digit is 7. Because 7 times 3 is, of course, 21, right? That's 1 at the end. Okay, so I know E is 7. So this is E as well. This is 7. Now, when I get 21, the 2 carries over, right? The 2 carries over from this multiplication. We carry over 2. Now, remember, let's see. So yeah, 7 times 3 is 21. We wrote the 1, we carried over to the 2. Now, some digit here times 3 plus the carry, which is 2, is supposed to give me this E here. Right? So what could D possibly be? What digit do I know that when I multiply by 3, I'm going to get something, and then I'm going to carry, I'm going to add the carry, and the resulting rightmost digit, the unit digit, is going to be a 7. Well, okay, what is it without the carry? Without the carry was 2, right? So without the carry, the unit's digit would be a 5. Would be a 5. So what do I know that would multiply 3 and give me a number whose unit digit is a 5? Well, 5 would work, right? D could be 5. Why is that? Because 5 times 3 is 15. And when I add the carry of 2, this becomes 17. And there's that digit 7. So 5 works. Let's try it. let's say D is 5. So that becomes 17. There's our 7. 1 carries over. So we carry over a 1. Now C times 3. So some number times 3, right, plus the carry of 1 is supposed to give me this D. What was D? It was 5. So without the carry, D's unit digit is a 4. Okay? So what number do I know that when multiplied by 3 has a unit digit of 4? Well, how about 8? 8 times 3 is 24, right? With the carry, this would be 25, and there's my 5. My D would be 5. So it seems that C is 8. C is 8. So again, 8 times 3 is 24. 8 times 3 is 24. With the carry became 25. There's my 5, and 2 carries over. Okay, so next, some digit times 3 is supposed to, with the carry, by the way, with the carry of 2, is supposed to give me an 8. So without the carry of 2, its unit digits is supposed to be a 6. So what times 3 gives me has a 6 in its unit digit? Has a 6 in it. How about 2? So what if B is 2? Well, 2 times 3 is a 6, right? With the carry, that would be the 8. So B, 6. 2, excuse me, not 6, 2. So 2 times 3 is 6. With the carry of 2, that becomes 8. Now B is 2. So now over here, some number times 3 is supposed to give me something whose unit digit is 2. Notice there's no more carry. We had 2 carry, we put it in, we got 8. There's no more carry. So some number here, some A, multiplies 3. Multiplies 3. And that number has a unit digit of 2. Well, how about 4? 4 times 3 is 12, right? There's my unit digit, 2. So it seems like 4 would work. So if A were 4, 4 times 3 would give me 12. That would be 2. I'd have 1 carried over. 1 carried over. And now look, finally, what happens? 1 times 3 is 3. I had a 1 carried over, so that gives me a 4 here for A, which matches my value of A up here, 4. And so we've deduced that my original number was 1, 4, 2, 8, 5, 2. And when I multiply this by 3, the result becomes the reversed version, right? So 4, 2, 8, 8, 5, 4, 2, 8, A, B, C, D. What did we have here? A, B, C, D, E, which was 7, and then 1 at the end. So the numbers have now been reversed. The ones. So the ones are reversed, and the other numbers go in the right order. I hope this makes sense. Actually, we missed a 2 here. We forgot a 2. D here is our 2. So 1, we have 1, we have 7, and then we have 2. D. There we go. So 4, 2, 8, 4, 2, 8, 5, 7, 1. 4, 2, 8, 5, 7, 1. This is a 7 here. Let's not forget, this is not a 2. The 2 was the carry. There we go. That's the result we got. So again, I hope that makes sense. Where did we start from? We started from very simple observation that if I want to get a 1 here as a unit digit, the only digit I know that multiplies 3 and gives me a result that has a 1 for a unit digit is 7, because 7 times 3 is 21 with a unit digits of 1. And then from then on, we just cascade to the left. But the tricky thing is to keep track of your carries. Notice how I was keeping track of my carries every time. So that's it. That covers the last exercise. This was the trickiest one. I strongly suggest you try this yourself again. Go through it again yourselves, and convince yourselves that you're able to do this. It's a really, really good exercise. And if things are unclear, just rewind the video, watch it again. Remember, you have first digit is 1, then you have 5 digits. So this 6-digit number, you're trying to multiply by 3. And the result is supposed to be the same last 5 digits. The 1 has now gone to the end. And your job is to find what that original 6-digit number was. And there you go, we found it. It's 142,857. All right, so that's the exercises for today. Like I said, today will be short. We'll pick it up. Again during the week, Monday. Have a great weekend, everyone.